Right, we're going to try this way instead, where I'm going to do the video of what I want to say before and just have it on loop, so you can hear it over and over, and it means that if it's not very good I can change it before I see it. So this song was on again because circles really didn't feature in the last one. As we said on the last speech, it could have been anything really. We didn't know what was going to be on paper 2 and paper 3 for the calculator questions because you just don't know. We knew what non-calculator things had come up, but you still had a massive choice. So you still got pi r squared sounds like to me, and if I need a circumference I'll use pi d. You still need to understand mass, density and volume. So remember, if you need a volume you can cover this up, and it's mass divided by density, or speed, distance and time. That did feature, but it may still crop up in something. So if I want to find the distance of something, I'll multiply speed and time, even on graphs. This is the higher trig stuff at the bottom. Okay, so it's only higher for this one. And this is the quadratic equation. So if you can't factorize something and you're asked to solve it, or it tells you you're going to have an answer that's going to be rounded, you're probably going to be using the quadratic formula. Okay, so it's not paper 2. All I'm doing is going through the first one and just re-going through the things that came up on paper, did not come up on paper 2, and there's quite a lot of things that didn't come up on this speech. So I may pause this and put another video on the end of it, but here we go. So basic expansion, multiplying whatever's on the inside. Excuse me, let's move this screen. Whatever's on the inside needs to be multiplied by the outside. So 4 times x is 4x, 4 times 2 is 8, and minus stays. Here it's the exact same idea, but you have a y as well. So y times y is y squared, so that is 10y squared. 5 times 3 is 15. X and y, when you times those together, just become xy. You don't have to do anything. This one, when you add x terms, it's just 4x. When you add different terms, so different layers, the same letter goes together. And if you look very carefully, I've got 2y take away y, which is the same as 2y take away 1y. So that stays as y. And 3 add 5, you always use the number. You always use the sign next to the letter term there. Okay, like that. And this one is where you're not adding or taking away, you're multiplying. So 4 times 5 is 20, and then as normal, powers, when you multiply, you add them. This one, it did feature on the foundation. It's not really featured on the higher very much at all. Okay, so the foundation students, it was a picture for you, so this one could come up without a picture. So the first step is to sort your bracket out. So I've multiplied it out. That'll get me 1 mark. And then you can see I'm starting to solve it by removing what's further away from the letter, so removing this. And those people in the know, BIDMAS in reverse works as well. Okay, this one, I then divided by 2 to get rid of that. 2, because it's multiplying now, so I've divided. You just keep doing the opposite. And then I've worked this out as a decimal, but you can leave it as a fraction. It is a calculator paper, so you can use your calculator. This one really hasn't featured for both exams, so it's about understanding what to do here. So you've got 2 letters. You remove the smallest letter by taking it away or adding it, depends what you've got. Okay, so this 2y is going to go, and this 7y is going to turn into 5y. Then I add 1 to get rid of the minus 1. Then I divide by 5 to get rid of that 5, and I get that solution. Now this could be in any type of situation. It could be in, let's say, I don't know, I'm just making something up on the spot. I'm literally drawing it on a post-it note. This could be on a parallelogram, where we have, I'm going to show you the picture that I'm really scruffily drawing now. So it could be something like this, where this equation is actually presenting this diagram, and we know that opposite angles in a parallelogram are equal, so it could be something like that. Okay, it could be from anywhere. The foundation students, you already had one of these, where it was derived from a picture. You had angles around a point. It was something like this. I can't really remember. Something like that. Something like that. And you have to do it. So foundation, don't expect to get it from a picture. Higher, do expect to get it from a picture. But again, nobody knows. We don't know how the examiners do these things at the moment. So higher, expect this. Foundation, maybe not. These are angles in a triangle, so they add up to 180. We know that if we add them all together, excuse me, let's get this in. This is my technical zoom. I'm pushing the screen back. But we know if we add them all together, we'll get 180. So if we add all the algebraic terms together, we get that, and we can make it equal to 180 and solve it as normal. Okay, so that is what you're going to have to do. So there's key things to remember. Triangles add up to 180. Quadrilaterals, four-sided shapes is 360. It could be anything though. It could literally be anything. It could be an isosceles triangle. And this is just me making it up. And the examiners will just be doing this idea. And what it will do, it perhaps will give you, I don't know, I'm just making another little beautiful picture up. It may say something like this and say find the top angle. Well, we know the base angles are equal, so we could make these two equal to each other, like I am, and solve that. So it just really depends on what you're presented with these ones. So use your basic maths knowledge to apply it into solving equations. Right, ratio has featured a little bit. I do mean a little bit. It was more like something to do with this question here, okay, but it went into a percentage question and so on. So I'll just run through this again. It's always about one part. So divide 180 into this ratio. You add them to find how many parts you've got so far. We know that 9 parts is £180. So we divide that by 9 and find out 1 part is 20. Okay, and then we multiply every single little bit by 20 to find that missing feature. This one is slightly different. Again, you've seen this a few times, but again, it hasn't really all completely featured. So you've got 5 to 7. Mr. P gets 20 more than Mr. C. So we know that 2 parts is worth £20 because that's how much more this person's getting. And then we divide it by 2 to get that. So I will get 50. It could say, what percentage does Mr. C get overall? And remember that percentage is a fraction times 100. So that will be 50 out of the grand total. So I could figure out that Mr. P has 7 times the 10. So he's got 70. So you can see him there. He's got 70. So overall, this is all technical drawings, obviously. Overall, I've got 120. So it'll be 50 out of 120 times 100. So it could ask you to turn it into a percentage, which is a fraction times 100, where the total or the original values are on the bottom and whatever you're after is on the top. It's a calculate paper, expect to see this. So percentage, fraction times 100. This one, again, is just because it hasn't featured again and again and again. So what it could be is a prism, which you'll see on the next page, which might look like this. I've just properly sketched one. Quite proud of myself there. So it could be this, and you have to find the area of that trapezium and times it by the length. Or it could just be a trapezium and find the area, and it might say this is a field and it sells grass seed in a certain amount per square meters or centimeters squared or whatever, and you have to calculate how many bags you need. So the process is straightforward. You add the parallel sides, which is these two. So 6 add 14, so you can see that there. You times by the height, and then we mean the height between the two sides, not this slanted edge. Okay, those who remember Mr. Goodhand never used a slanted height, he used to say. So times by the height, use a calculator, and then divide by 2. This is a calculator paper. So do it in your calculator, but write everything down. Okay. The next bit is the idea of finding the volume of a trapezium. You need to find the areas of these shapes. So base times height divided by 2. 8 times 4 divided by 2. That'll find that in times by the length. Pi r squared times by length. Or even if it's a trapezoid one with a trapezium on the front, find the trapezium, times it by the length. Okay? Right, so where are we up to? This has not come up on anything, so expect to see this, higher and foundation. So it's where you've got a table. It could just be a table like this, so that bit on my hand is not there. And you have to add all this to it. You don't need to add the labels, but you need to be able to add these midpoints and midpoints times frequency. You need to be able to do that, not write down the labels. You don't even need to draw the table. You can just do it on the right of it and just make sure it's in the right place. I mean, to be honest, you could even do it down somewhere else. The examiner is made to look for these midpoints and is made to look for you doing this. So what I want to do is show you how to find the midpoint of these. So this PowerPoint is obviously doing it, but I want to show you how you find the middle of something that you might not be happy with. So how do you find the middle of 21 and 25 if you're not sure? So let's do that. So 21 and 25, you add them, press equals now. Get that. If you just press divide by 2, which I'm going to do now straight away, it won't work. So you add them and then halve them. So the midpoint is 23. So that's how they got 23 there. So I just chose that one at random just to show you. But that's how you find the middle of awkward ones. So if you have to find the midpoint and it's all dodgy decimals or something, add the two numbers. So look back, add the two numbers together, get your answer. Oh my God. Then divide it by 2. Okay, make sure you're doing that order. And then you literally multiply these out. So 2 times 3, 9 times 8. And you do it all the way down. And then you get the grand totals and you add and divide. So we've added these and we've divided. Okay, this is estimating the mean. Midpoint times frequency. So times these two together. Add these, okay? You don't want to use this column ever again. You don't want to use this column ever again. So you know you only add these two together. Okay, this is a little bit different. The modal class is the group that has the most people in, or the most things in. So this group has the most people in, so that is the solution. This one is the median, so you need to find where the median is. There's 91 people, so the technique is to add 1 and halve it to find the 46th person. Okay, if I just get a post-it note on the go. Then, when you've got that, you know you're at the second person here, then the 11th person here. What's this one? The 26th person here. I'm after the 46th one. So when I finally add this one on, I'm there. So this is the solution to the median. Okay? So that's how you do that one. It's nice and straightforward. It could be a more complicated label, but it doesn't matter. You just write it down. Again, this hasn't really featured. Corresponding angles are in the same position, year 11. The same exact position, look. Alternate angles, alternate. They change side, look. See how they changed over? So people draw the zigzag around them, but you can see it's changed side. Okay? So you have to say corresponding angles are equal, or alternate angles are equal, or alternating angles are equal. It doesn't matter. You then could know that opposite angles are equal, or you could do co-interior equals 180. It just depends on your experience here. Again, running through this, expect to see this, okay? Sorting out simultaneous from the question, okay? So I've gone through it many times, but you can see 2 adults and 3 children equal that. 3 adults and 5 children equal that, so I'll set these up. You then need to make something the same. So I've made the C's the same by times and by the opposite number, and then we can sort it out. Remember how to do it. Stop, same sign take away. So these are both adds, so we're going to take these two away to get it going. Okay, if it was a plus and a minus, we'd add them together. Still has not featured, so expect to see it. SOHCAHTOA has not featured. So remember to label the two sides. This is the opposite side to this angle. It's all about this angle. This is the adjacent side because it's in between the two. So when we label it, we've got OA, so it's TOA, okay, which is tan angle equals O over A. So O is X and A is there. And this rearrangement is where the number goes across. Okay, and we bang it in the calculator. We'll put it in the calculator and round it. Write down the full answer first, then round it. Next one, same as, label it again. This is where the X is on the bottom, and it just depends how you've labeled it. So this is adjacent, so it's cos. So cos equals adjacent over the hypotenuse. So 6 over X is how you start, adjacent over hypotenuse. Just goes in like that. And then this is this rearrangement where they swap. And it goes in your calculator using the fraction button. And the last one, finding missing angle is quite straightforward. You label the two sides. This again is because you've got A and H, the adjacent hypotenuse. So you've got cos X, because that's the angle, equals 8 over 11. And then it's always cos to the minus 1. That's the second function button. Complete the square. So remember to halve this value, put it there, square it and take it away and bring it back. The language is still going to be the turning point and the minimum point. Okay? To find the minimum point of a curve, using this format, it will be positive or the opposite value to this. Okay, opposite sign to this one and the same as that one. So you can see it's positive 3 minus 7. Iteration did not feature. Expect to see it. Today is Monday when I'm doing this before we see you for 2 hours. So hopefully it's been discussed at length. Okay, or at least a bit for the higher students only. First, you have to make it equal to 0. Then you have to substitute 0 in, becomes a minus or a plus, and then substitute 1 in, it should change sign. So if it has changed sign, it will have a solution. The next one, this is telling you how it should look. So if you do this, cover this up, you know that you've got to take away the cubed x first. So take away this one first. And then to make it happen, so it's got 4s on the bottom, then you divide by 4. Okay, and you can put it straight into that format. Okay, the next one, you don't have to worry about this equation. It's been put in this format for you. So the first thing it's saying is substitute 0 in 3 times to find an estimate for this solution. So we just keep putting in the next answer. So this was when we put 0 into the equation instead of this term. So 0 cubed. Then I'm doing a quarter cubed. Now I'm doing this solution cubed, and now I've done it 3 times. That's the solution. So we'll keep putting the solution back in. Okay. I don't know why it runs through again. And this is just a quick reminder about functions. The order is x into g, g into f. This one, x into f, f into g. So it's going from the right. This one is saying put 1 into g, then put that answer into f. So let's have a look at that. So 1 is gone into g, so it's 1 plus 1. Then that solution is 2, obviously. Then they've put 2 into that. This one, they've put 3 into g, so 3 goes in there to become 4. And then 4 goes into that to become 16. And this is just where they substitute the algebra in. And this one, I'm rushing through because I think most of you should have been shown on Monday, this video. This is where you substitute in just the algebraic terms of g into f. So this is going to replace this x. So it's going to be 3 times the whole bracket. And then expand and simplify. Same process all the way. This one is f squared, so it's putting 3x plus 2 into 3x plus 2. So you can see this is where the x was, it's just become the full term. Okay, right, so that's that part. There are other things that you need to focus on, okay, but this video is already 17 minutes and I don't want to really give you too much. So I'm going to leave it there. Good luck. Okay, some of you worked really hard for this. Okay, remember it's about your determination on the back of the hired paper, recognising questions that you've been trained with and applying them in a weird way. For those who are going for your 6s, it's about smashing the first half and really reading these questions to see where you're going to steal some of these hard marks from and nailing some of the basic questions, okay, and really checking your solutions. Those people on foundation for 5, it's really important that you're getting that first half of the paper, the basics on, correct, double checking your work. Okay, using that change button on your calculator today will be massive advantage where it's saying change, I don't know, 0.12 into a fraction. If you just press equals, it's doing it for you. Okay, so remember to use this change button to your advantage and then really read those back questions. Okay, because there's lots of people on the foundation paper that will find those tricky and you've got to really go for that. And those people are trying the foundation to secure the 4. Get that first half done as best as you can and then try and steal marks from the back half. Okay, so good luck. I'm hoping this video was of some use to you. Okay, but it was a massive video, so I suppose you'll be glad it's over. Okay, right, see you when it's all done.